Good morning, students. Today we have come with another topic of class 11 subject IP from chapter 1st, and the topic is logic gates and its types. I repeat, today's topic is logic gates and its types. This topic is presented to you by Ankur Pandita, teacher, BHSS, Drugmulla. Now, before discussing logic gates and its various types, let me give you the concept of Boolean algebra. Boolean algebra is an algebra that uses true values, true for 1 and false for 0. Boolean algebra वो algebra होता है जो सिर्फ true values का use करता है. 1 डिनोट करता है ट्रू को, 0 डिनोट करता है फॉल्स को. बाय डिफाइनिंग सेंटेंसेस यूजिंग ट्रूथ वैल्यूज एंड परफॉर्मिंग ऑपरेशंस ऑन दीज ट्रूथ वैल्यूज वी कैन वर्क आउट द कम्प्लेक्स ओवरऑल कंक्लूजन ऑफ कम्प्लेक्स स्टेटमेंट्स. इन ट्रूथ वैल्यूज़ का यूज़ करके और उन पे ऑपरेशन करके हम वे कॉम्प्लेक्स स्टेटमेंट्स को कंक्लूड कर सकते हैं. इट वाज डेवलप्ड बाय ब्रिटिश मैथमेटिशियन जॉर्ज बूल इन 1854. बूलियन अलजेब्रा को डेवलप किया गया है ब्रिटिश मैथमेटिशियन जॉर्ज बूल ने 1854. नाउ लुक आवर मेन टॉपिक, logic gate. What is logic gate? A logic gate is an electronic device which takes one or more logic level inputs and produces a single logic level output. इसका मतलब क्या है? लॉजिक गेट एक इलेक्ट्रॉनिक डिवाइस होता है जो एक या एक से ज़्यादा इनपुट्स लेता है और एक सिंगल आउटपुट हमें देता है. दैट इज वो आउटपुट लॉजिक होता है, लॉजिक लेवल पे होता है. इन अदर वर्ड्स, ए लॉजिक गेट परफॉर्म्स ए बूलियन ऑपरेशन. तो ये बूलियन ऑपरेशन करता है किन पे? एक या एक से ज़्यादा लॉजिक इनपुट्स पे एंड प्रोड्यूसेस ए सिंगल लॉजिक आउटपुट, और हमें एक आउटपुट देता है. मैं रिपीट करता हूँ, एक लॉजिक गेट हम उसे कहते हैं कि एक इलेक्ट्रॉनिक डिवाइस होता है जो एक या एक से ज़्यादा लॉजिक लेवल इनपुट्स लेता है और हमें एक सिंगल लॉजिक लेवल आउटपुट देता है. तो इसी लॉजिक गेट में एक जो हम ऑपरेशंस करते हैं उसको हम बोलते हैं ट्रूथ टेबल. व्हाट इज ट्रूथ टेबल? ए ट्रूथ टेबल इज़ ए वे टू शो द फंक्शंस ऑफ ए लॉजिक गेट. ट्रूथ टेबल से ही हम दिखाते हैं कि कैसे एक लॉजिक गेट फंक्शन करता है. इट मैप्स द आउटपुट स्टेट्स फॉर एवरी पॉसिबल कम्बिनेशंस ऑफ इनपुट स्टेट्स. इसमें हम हर कोई कम्बिनेशन लेते हैं, डिफरेंट इनपुट्स लेते हैं और हम देखते हैं कि उन इनपुट से हमारा आउटपुट कैसा होगा. द सिंबल 1 फॉर ट्रू एंड 0 फॉर फॉल्स आर यूजुअली यूज्ड इन ट्रूथ टेबल्स. मैं रिपीट करता हूँ, ट्रूथ के लिए ट्रू के लिए हम 1 सिंबल यूज़ करते हैं और फॉल्स के लिए 0. जहाँ पे लॉजिकली वो स्टेटमेंट ट्रू होगा उसको हम रिप्रेजेंट करते हैं 1 से, और जहाँ पे लॉजिकली वो स्टेटमेंट फॉल्स होगा उसको हम रिप्रेजेंट 0 से करते हैं. Now, types of basic logic gates. There are usually 7 types of logic gates. That is AND gate, OR gate, NOR gate, NAND gate, NOR gate. I have mentioned only 5. Sixth is exclusive OR and seventh is exclusive NOR. But as far as your J&K syllabus is concerned, we have to study these 5 in detail. That is AND gate. First is AND gate. Second is OR gate. Third is NOR gate. Fifth is NAND gate. Fourth is NAND gate. And fifth is NOR gate. Today in this topic I will discuss 3 types. First 3, that is AND, OR and NOR. Remaining 2 I will be discussing in the next topic. So there are 7 types of logic gates, but we have to study 5, and in this topic we will study 3. This lecture. Now first use AND gate. You are seeing the diagram. This is hand-made diagram. This is the diagram of AND gate. Here there are 2 inputs, input A and input B, and the single logic level output is drawn out of that diagram. Y is referred to as output. That is called in A into B. And next in the diagram is shown the truth table. Now we have written 2 logical level, taken 2 logical level inputs and their combinations are shown, because 0 0. These are combinations of 2 inputs, 0 0, and 0 into 0 is equal to 0. That is, Y is taken as shown as output. 0 0 0. When A is 0, input A is 0 and input B is 0, output is also 0. You can calculate just by multiplying A into B. 0 is into 0 is equal to 0. 0 into 1 is equal to 0. 1 into 0 is equal to 0. 1 1 is equal to 1. These are every possible combinations of the input values A and B. 0 0 0 1 1 0. These are the possible combinations of A and B, and from these possible logic level combinations, output Y is given. This is equal to 0 0 0 1. And from this truth table we can conclude that output of AND gate is true only when both the inputs are true. Otherwise, in all cases, the output is false, which is represented by 0. I repeat, AND gate can be defined as the gate in which output is, here you can see in the truth table, output is true, that is 1, in only last case when both our inputs are true. In other cases, output is false. Thus, AND gate can be defined as the gate in which output is true when both inputs are true. In all other cases, the outputs are false. Now we can define from this diagram. We have stated AND gate. Now we can easily define AND gate. AND gate can be defined as the gate in which output is true if both input A and input B is true. Otherwise, the output is false. So diagrammatically we have understood the function of AND gate. Now the second gate is OR gate. Now look at the handmade diagram. This is the AND gate, diagrammatically shown the diagram of the OR gate. Similarly, A and B are taken as two inputs and the output Y is drawn out of these two inputs. Y is called A plus B. Y is called A plus B. This is generally seen that two inputs are being added in the OR gate. Now look at the truth table. We have similarly taken two inputs A and B, and the output is represented by Y. Y is called A plus B. 0 0 0 1 1 0 1 1 are the possible combinations of different inputs. These are combinations. We have 0 0 0 1. These are combination of various inputs, the two inputs which we have taken in the diagram, two inputs A and B. And the output 0 plus 0 0 0 plus 1 1 1 plus 0 1 1 plus 1. In this binary arithmetic, 1 plus 1 plus 1 is not 2. It is 1 plus 1 is 1, because we have only two symbols, 0 and 1. So from this diagram we can refer OR gate as the gate in which output is true. Output, if only one of the input is true, the output is true. Otherwise, the output is false. So how can we define as OR gate? OR gate can be defined as the gate in which output is true if input A is true, or basically in OR gate, if one of the inputs is true, similarly both of them can be true, the output is true. Otherwise, the output is false. And the last which we have to discuss in this topic is NOT gate. NOT gate diagram. In the diagram you have seen, taken A is a single input in which has been taken, and the single output has been generated Y. Y is the complement of A. In NOT gate, the output is the opposite of the input. If 0 is the input, 1 is the output. If 1 is the input, 0 is the output. Thus we can easily define NOT gate. The NOT gate is also known as inverter, simply because it changes the input to the opposite. When 0 is the input, our output will be 1. When 1 is the input, output will be 0. The NOT gate accepts only one input, and the output is opposite of the input. I repeat, the NOT gate accepts only one input, and the output is the opposite of the input. NOT gate is simply known as inverter because it inverts the input. The output is the reverse of the input. Students, in the next lecture we will be discussing the remaining two NOT gates, NAND gate and NOR gate, and also I will give you a concept of two other gates, exclusive OR and exclusive OR. Students, that is it for today. I expect you to revise this topic and note this topic on the notebook. uh, this is very important topic from the examination point of view. You students, stay at home, stay safe. Thank you.